so here we have a fraction, and we know from our discussion in the previous questions, when we have a fraction, we want to make sure we can say it's continuous provided x minus 2, the denominator, is not equal to 0. So what we're finding here is that it's continuous if x is not equal to 2. Now, to classify the type of discontinuity we have, this one's a little trickier here because we can't just cancel absolute value with something that doesn't have an absolute value. So in order to answer the question of what type of discontinuity happens at 2, we need to go back to the definition of the absolute value function. So the absolute value of u is defined as negative u if u is less than 0, and positive u if u is greater than or equal to 0. So applying that piecewise function idea to our particular absolute value, which is x minus 2, we would have that this numerator is really represented as negative quantity x minus 2 if x minus 2 is less than 0, and positive quantity x minus 2 if x minus 2 is greater than or equal to 0. Now, the problem here is, like, if you look at the little piecewise function, to the left and to the right of 2, we have different definitions. So it's not going to be that something just automatically cancels out, because at this split point, which again, if you add 2 to both sides, you would get x is less than 2. At that split point, we've got to really think about what is happening. So this particular situation, yes, we have a fraction, but really what is going to drive the type of discontinuity is the fact that we have a piecewise function, and so we are interested in what the limit is from the left and from the right. So if I were to take the limit from the left, I would be using the left-hand side here. I would be using this negative x minus 2, or negative parentheses x minus 2 quantity for the absolute value. And I would still have the original denominator of x minus 2. Okay, so again, what we're trying, I'm sorry, I keep hitting the table here. So what we're trying to do is our f of x function is absolute value x minus 2 over x minus 2. To find the limit from the left, we would have to use this piece. So I'm substituting in for absolute value negative quantity x minus 2. Now, what I need is that limit from the left is equal to the limit from the right, and then that would ensure my two-sided limit would exist. So in this situation, I would look at from the right. So now for this absolute value, I would substitute in just x minus 2 over x minus 2. All right, so my limit from the left will be defined by the negative parentheses x minus 2 in the numerator. Limit from the right will be defined by this piece, which will just be x minus 2. Now, if I look at just evaluating this limit, we now see that these x minus 2's cancel out, and we're left with negative 1. And when we're left with negative 1, there's nothing to plug in. That is our limit. On the right-hand side, though, we see that these x minus 2's cross out, and we are just left with positive 1. So what this is telling us is that the left-hand limit is not equal to the right-hand limit. Okay, and if you were to actually draw this little picture, what you would see is that from the left you have negative 1, and then from the right you have positive 1. So you would have a little step or a jump in your graph. So the fact that the left-hand limit is not equal to the right-hand limit, that means that there is a jump discontinuity at x is equal to 2. Okay, so with this question, it comes out at the beginning as just a fraction, but when you actually dive in there and look at the piecewise function that is involved in this absolute value, you're really dealing with a piecewise function. And remember from our little chart over here, when we're dealing with a piecewise function, we have to look at the left-hand and the right-hand limit, and if they're not equal, then that means we have a jump in the graph.